10 days.
Yeah.
I'll tell you something.
But I will tell you something. If you wanna, we can spend more time in
Yes, we can extend the
Saturday
time.
or Friday. Not both, but one of them we can spend time if you
You
want.
can personalize the stay.
Normally in these business days, I know that you will come at 9 o'clock and like yesterday, you spend time in that lab. Well, it was easy. I know that if I give it to you in 8 a.m., you will solve it quickly. But since you are tired, I know it will be hard. So, but since Friday and Saturday, it is day off, right, for you both? Yeah. So yeah, we can spend more time than these 2 days. Now, spanning table to call. To understand spanning table to call, check this topology. I have 2 switches, and for redundancy, we need to have 2 links. Because if I have only 1 link connecting switch 1 to switch 2, and this link goes down, that means they are isolated now and they cannot communicate with each other. Again, the concept of single point of failure. I don't want to have a single 1 link act like a single point of failure, so I will need to have another link. The issue here that if this PC is doing broadcast, what will happen? Normally switch state, I will take the traffic, that is broadcaster traffic, I will send it to all interfaces except the source interface. So we will give it to everyone, including this interface and the lower interface. Let's see the upper interface. When the broadcast coming to switch 2, what switch 2 is going to do? He will give it to all interfaces except this one. That means he will send it back. Right? And when it comes back here, this switch will give it to everyone except this one, and we will have a loop, switching loop. And it will never end. You need to remember something. If we are talking about IP level, we can have something stop the packet from moving around for infinity. We call it time to live. Each packet has a time to live. Time to live. For example, let's say my time to live is 128. That's mean to reach the destination, I can go through 128 hop or router. But after that, router number 128 will drop these packets because time to live is equal 0. We don't have such a thing in Ethernet header. So this loop will continue happening. They said, okay, in this case, we should have one of these things not working. Let's assume that this interface is blocked. It's not working anymore. In this case, the loop will stop. We will not have a full circle. We are cutting the circle, right? Now, to make this interface block, they said switches should talk to each other and should have a protocol helping them to talk to each other. And they should choose one of the switches like the boss, the master switch, and we will call it root bridge. So they need to elect a root bridge, and then the root bridge will say, okay, let's block this interface. Let's do this, let's do that. And spanning tree protocol is the protocol will help us to have such a thing. Now, how the switches will start sending to each other information about their own, what we call it, bridge ID. The switches need to elect a root bridge. And to elect a root bridge, let's assume that we all are switches. In this case, I need to send you my bridge ID, and you will send me your bridge ID, and I will do the same with the others. Later, we will decide that the best root bridge is here. If this is the best root bridge, if this is the best bridge ID, in this case you are the root bridge, you are the boss. How we or why we choose him as a root bridge? Because his bridge ID is the lowest bridge ID in all switches. So the lowest bridge ID is the winner, and he will be the root bridge. Deal with it like this. Okay, how I will send you the bridge ID? Normally I will send you the bridge ID using a frame, but this type of frame we call it BPDU, Bridge Protocol Data Unit. Also, I want you to remember something. When we are saying bridge, it means switch. But they took it from old time when we used to call it bridge. They didn't change it. BDU, Bridge Data Unit, Protocol Data Unit, if you remember it, in OSI model. Layer 7, layer 6, layer 5, layer 4, remember that, OSI model. And you remember in layer 4 we have segment with TCP or UDP header, then I have packet with academically, we don't call it segment packet frame. We call it BDU. And we call this BDU has an encapsulation, and this one has an encapsulation, and so on. So they took the term from there, and they say this BDU is for bridge. It is for bridges when they want to talk to each other. So when I say BBDU, that means it's a frame, has an information related to the switches themselves, and they will use it when they are talking to each other. I will not send the BBDU to a host machine, and I should not receive a BBDU from a host machine, right? Now, so this is the mechanism that we will use to send our bridge ID, and we say the lowest bridge ID is the winner. And you have the lowest bridge ID, or he have the lowest bridge ID, so he's the root bridge. Now, what we mean by lowest bridge ID? The bridge ID itself has two parts, priority and MAC address. And normally, priority is a number, and it has a default value, 32,600 something. In this case, you will tell me if we all have the same priority, in this case, how we will choose who's the root bridge? I will tell you, we will check for the second part, the MAC address. Lowest MAC address is the one. But remember something. If I change the priority, in this case, we will focus on priority. Switches will focus on priority, will not focus on the MAC address. In another meaning, if he is the root bridge, and you will say, wait a minute, my MAC address is smaller than him, than his MAC address. I will tell you, yes, but the priority here is less than him. So we always focus on the priority. If the priority are the same, we will check the MAC address. This is how the bridge ID works. There's two parts, priority and MAC address. We check the priority. If it is by default, and it is by default, has the same number in all switches, in this case I will check the MAC address, and lowest MAC address will be the winner. And in this case we choose the root bridge. Another concept I need you to understand. They say any two interfaces, or what we call it a segment, one of the interfaces should be called designated port, and the other should be called root port. These are just names for the two interfaces facing each other. If you have a root bridge, let's say he is a root bridge, and he is connected to me, I'm non-root bridge. His interface will be designated port. My interface will be root port. I cannot be designated port connected to root port and he is the root bridge. It will never happen. So always the root bridge, all his interfaces is designated port. Other side, other non-switch port, other non-root bridge, they will be root port. Also, there is some exception here. interfaces, whatever in his switch or in my switch, root bridge or non-root bridge, if these interfaces connected to host, this is also will be designated port. So he's the root bridge, I am non-root bridge. He's designated port, I am root. Okay. But what about another two machines connected to different interfaces on him and two interfaces? I have three interfaces connected also to host. It will be designated port. And for him, it will be also designated. Now, let's check this topology. According to the BPDU sent between these switches, they decide that switch 1 will be the root bridge. Since I am the root bridge, that means this is a designated port, this is a designated port, this is a root port, this is a root port. And later we will talk about who is going to be designated and root. Now, there is something in the spanning tree, we call it coast. And coast, slides. According to the coast, if forget this old spanning tree coast, we are using the new. If my interface is Ethernet, my coast is 100. These two is fast Ethernet, right? The coast is 19. And here it is 19. Now, switch 2 will tell himself what is the lowest cost I need to spend to go to the root bridge. 19, 19, 38. 38 or 100?
38.
38. Even if I'm directly connected to the root bridge, but it is Ethernet. Here I have fast Ethernet, cost is this. Once switch 1 will receive this information, it's the root bridge, he will tell switch 2, okay, you know something? This interface will be blocked. This interface should not be running anymore. And now, we don't have a loop. We don't have a circuit, right? All information will be like this. And this one closed. Now, let's finish this topology with which interface will be designated port and root port. Designated port, as we said, any segment should be designated port and root port. Think about it like this. The nearest interface to the root bridge. If we check this topology now, I will say this interface is not the nearest to the root bridge. This one is blocked, so he needs to go like this. This one is the nearest to the root bridge, right? So this is designated port, and this is the root port. Got it? Spanning tree work in different methods and different flavors, let's say. We can have spanning tree, a classic spanning tree, that working as a one process or one instant for all VLAN. This is the normal thing. Or we can have bare VLAN spanning tree protocol. It means how many VLAN we have. VLAN 1, 2, 3. So I will have 3 spanning tree protocol processes. Each one is serving and doing his job for each VLAN. Now, also you have something new, especially here in switch. We don't saw it before in CCNA level. MST, or multiple spanning tree protocol. It means one spanning tree process for a group of VLAN. So here, the relation is one spanning tree instance to all. Here is 1 to 1. Here it is 1 to many, or a group. Now, think about it. If I told you I have VLAN 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Maybe you will ask me, okay, one spanning tree protocol instance will serve all of them. I'll tell you, okay, but in this case, you have one topology, and in this topology, there is an interface here, not working. There is a link here, not working. And you will tell me, okay, I don't care, it's Ethernet. But what if it is also fast Ethernet? Okay, what if it is also fast Ethernet? In this case, I would say, I need to use it. So maybe I can go to these switches and tell them, you know what? Let's create a spanning tree for each VLAN. And for VLAN 1 and 2, the root bridge is switch 1. But for VLAN 3 and 4, switch 2 is the root bridge. So now you have two root bridge, but each one is working for specific VLANs. In another meaning, if this interface is blocked for VLAN 1 and 2, but he is running for VLAN 3 and 4, and maybe this interface is blocked for 3 and 4, but working for 1 and 2. You got it? So it is good to have something like that. Another important thing here in the spanning tree is, Yasser, you say that maybe this is a fast Ethernet. In this case, what is the reason that makes switches make this one block, not this one? Let me show it to you in two switches. Here we have two switches. This is fast Ethernet 01, this is fast Ethernet 01, this is fast Ethernet 02, this is fast Ethernet 02. And they start exchange BBTU, and they decide the root bridge is this one. Now tell me, which link will be working and which link will not be working? Which interface will be blocked? First of all, for sure, not here. Root bridge will never have a block interfaces. The non-root bridge is the one that will have a blocking interface. So in this case, it is one of these two, right?
Yes.
Which one has the highest interface ID? Two, right? So this is the one that I will do. So when the cost is equal, I will check the interface ID. Take with it like this. If the cost is equal, in this case, I will check the interface ID. If it is equal, I will check something called interface priority. And so on. Now,
Can you explain this interface ID?
interface ID. Fast Ethernet 01 and Fast Ethernet 02. This is interface ID, right?
Yes.
He said if it is 2 and you have 2 and 1 in this link, if I want to block something, it will be the 2, not the 1.
But here you mentioned that
Both are
there is
good.
only priority in MAC address.
Yeah, this is to choose the root bridge, guys. Here I'm talking about which one will be blocked. According to priority and MAC address, the first switch is the root bridge. Done. So let's forget now the idea of bridge, the concept of bridge ID. Now we have another concept, which interface will be blocked. And as I said, for sure it is not the interfaces belong to the root bridge. Root bridge will never have interfaces blocked. Okay? So it for sure will be one of the two interfaces in the left side. Okay, the left side, if these two interfaces, one of them is fast Ethernet and one of them is Ethernet, for sure the Ethernet will be, but what if both of them is fast Ethernet? In this case, the highest interface ID, which is fast Ethernet 02, this is the meaning of interface ID.
Okay.
Also, in this case, this one will be blocked. I want to tell you advice for spanning tree protocol. You need to understand it, but don't play with it a lot, because it can make all your network goes down. But it is important to understand what's happening. It will help you if you want to troubleshoot. But normally we don't like to play, because you can actually tune everything. You can even tell him, you know something? No, choose fast Ethernet 01. Fast Ethernet 02. How you can do that? Both have the same cost, right? 19, right?
Yes.
I will go to fast Ethernet 01 and I will tell him, hey, your cost is 20. So the fast Ethernet 02 cost is now 19, and it is better, right? You understand this? Use me. These two interfaces has the same cost.
Okay.
19, right? In this case, I will choose the fast Ethernet 02, the highest interface ID, and I will make it block. If you want to tune this or make it in the opposite way, in this case, I can go to fast Ethernet 01 and I will tell him, hey, your cost is 20.
So we can assign the cost by ourselves?
Yeah, you can play with it. But that's why I told you don't play with it. Because you are changing a lot of things. Just let me, yeah, here you can see for electing designated port, lowest port bridge ID, root port, sender bridge IDs, lowest sender port ID. Yeah, remember, any interface in the switch is spending some time to learn things and listen to BBD. In another meaning, if I say if I have a spanning tree protocol in my network, what is the states of the interface? I will tell you, maybe it is disabled, shut down. Maybe it is blocked, or maybe it is running. It is forwarding. But remember something, to be a forwarder or forwarding interface, you will spend 30 seconds first trying to listen and learn for BBDs, because you don't know who's this guy. Maybe he's a switch. Let me check. Okay, what is his MAC address? Oh, this looks like a host, and he's spending time with 30 seconds. This is what we call it listening and learning. He moved from disable or blocking to listen, learn, forward. So even if the interface is not even disabled or blocking, you don't have any cable, and you put a cable. Now he is moving from this non-state or null-state things to forwarding by going to listening, learning, forward. Listening and learning, each one of them will take 15 seconds. That's why I say 30 seconds. Okay? The 15 seconds, we call it forward delay. So he spent 2 forward delay. Right? You can tell your interface, you know something? Why listening and learning? Do you think that we have a switch there? No, we have a host. So don't spend time to listen and learn for BBDU. Host does not send a BBDU or receive it. So I can go to the interface and tell him you are port fast. I will use a feature called port fast. And in this case, I'm telling the interface, don't spend time in listening and learning. Go forwarding directly. This is what we call it broadcast. There is another thing that I want to also talk about it. You see this Ethernet 0 and switch 2, he's blocked, right? Why he keep himself blocked? Because root bridge is sending him hello message every 2 seconds. A BBT telling him, keep yourself blocked, please. What if the link between switch 1 and the switch 3 goes down? In this case, the switch 1 will say, know something? I will not send any more hello messages, will keep blocking. I want him to go up. The problem with switch 2 is, he didn't receive the first hello messages after, the first hello message after 2 seconds. What he will do? He will wait. Another 2 seconds, another 2 seconds. He will wait for time of sending 10 hello messages. In another meaning, he will wait 20 seconds. And once he finish this 20 seconds, he will say, okay, this is my maximum age, 20 seconds. In this case, that means something happened bad there. I need to be the forward. I need to move to forward. I'm blocking. I need to go to listening, 15 seconds. Then learning, 15 seconds. Then I'm forward. In another meaning, if link between switch 1 and switch 3 goes down, I will wait 50 seconds, 50 seconds, till this Ethernet 0 become forward. 20 seconds for waiting the hello and it is not coming, and 15 seconds for listening, 15 seconds for learning. You got it? There is a command you can apply in the switches called backbone fast. It's say if one of the switches goes down, the link goes down, don't spend all this 30 seconds for listening and learning. Try to make it 1 or 2 seconds and make everything goes up. You're trying to solve this 50 seconds. The BBTU itself has 2 types. We have the normal BBTU that's sent to you as a hello messages, or maybe in the beginning when we want to elect the root bridge, right? So you will find the BBTU, in this BBTU, we'll find a lot of things like maximum age, hello time, forward delay timing, what is my bridge ID, if we're still in the election stuff. This BBTU, we call it configuration BBTU. Now, we have another type of BBTU. It's called topology change notification BBTU, or sometimes we call it TCN, topology change notification, topology change notification, TCN. In spanning tree, what's happening is, if I felt that something wrong, one of the links goes down in my switch, I will send to the root bridge and telling him, hey, I have TCN. This is a TCN. What I'm telling you, by the way, this link goes down. You are the root bridge, you are responsible to take this TCN and send it to all other switches, so they are aware now that something wrong happened with that core switch. And by the way, when you are sending TCN, the other side should send you TCA, acknowledgement, saying I received. Okay, good, I got it. That link goes down, okay, I will go to the others. And the others will also say, okay, root bridge, we got it. This is the classical spanning tree. We have another type of spanning tree. We know now we have 3 types: spanning, the normal spanning tree, Berville spanning tree, or multiple spanning tree. But there is something with spanning tree. Protecting now. Yeah. There is something, some enhancement they made it for a spanning tree, and they call it rapid spanning tree. The main difference between spanning tree that we was talking about and rapid spanning tree is two things. We have some other things, but two main things, two major things. First, if a switch felt something wrong, they say, why you are sending the TCN to the root bridge and wait the root bridge to tell the others? No, give it to the root bridge and the other directly. Make everyone quickly knows that there is a change happening. So with Rabbit, I don't need to send the TCN to root bridge only and wait root bridge to do it for the other. No, I will send it for all. Also, what they said, no need to spend two forward delay. Two 15 minutes, 15 seconds, total 30 seconds. In another meaning, let's have only learning, no need for listening. So this listening does not exist in Rabbit spanning tree protocol, and this is what make it faster. That's why we call it Rabbit. You got the idea? And we have Rabbit spanning tree, Rabbit bare VLAN spanning tree. This concept is there. Two things that Rabbit added to his concept. He said, if this interface is blocked and he is our root port from the beginning, but now he's blocked like Ethernet 0 here, switch 2. He called it alternate port. If the interface that it is blocked, I know if he is going to be forwarding, he will be a designated port, not a root port, like down. I assume that switch 3, fast Ethernet 02 is blocked, DB is blocked. Assume that. Okay? In this case, we call it backup. Backup port means it is a blocked port, but when he is going to not be a blocked, it will be a designated. Alternate, it means this one is blocked, but when he is not blocked, he will be a root port. Also, so as you can see, this is Rabbit. And by the way, he's talking, he called blocking discarding. This is the term that he's using. There is only one thing that I want to show to you. Okay. There's three terms Rabbit spanning tree is using with boards. Sometimes you will find him calling a board H board, shared board, point to point board. If he says H board, that means this board is connected to a host or a server. If he says shared board, that means I'm connecting to another switches where different switches connected to me, or maybe frame relay. Point to point board is point to point, as it means.
Point to point is for what?
Point to point is the full duplex. It means two switches connected directly to each other. And for example, if I'm a switch and you are a hub, this will be shared port. If I'm a switch connected to a router or another switch, this is point to point. I explained it to you. By the way, the slide I made it to be like, it is not all, I didn't bring the stuff on it from only the books, from different books. So you can deal with it like a book or a summary. It's not a slides for illustration. Multiple spanning tree protocol. This is something new. Guys, in multiple spanning tree protocol, we have the concept of one spanning tree will work for a group of VLAN, not only for one VLAN or for all VLAN, no, a group of VLAN. The commands, let me show it to you, because if you saw the commands, it will explain a lot. But I added for you somewhere. No, this one. Yes. Let me show you what's up. The command is like this. First of all, if you want to tell your switches that we will use MSTP, we call it MST. In this case, you need to tell them that our spanning tree mode will be different. Okay? So normally we use spanning tree mode command. You can this command you can use to tell the switches that we are Rabbit or MST, and you would say MST. That's me. The switch now is a part of a cloud of switches that will run this MST. Spanning tree MST configuration. Here you are going to telling the switch that I need to start configuring the MST. So you are going to the sub mode for configuration, for MST configuration by typing this command. Then you need to have a name. We call it region name, because what's happening here is we will have, like, let's assume we have one switch here, another switch here, and both of them will use MST. One spanning tree for a group of VLAN. So they say, you know something, VLAN 1, 2, 3, 4, this is one instant, and another instant for VLAN 100, 200, 300. So 2 instances I have. These 2 switches will be virtually, for others, is like one switch. Okay? In another meaning, what if you have here your HP switch and he doesn't understand MST? So I am not understanding what you are doing there. But I am connected to you using the normal spanning tree, the classic, or sometimes we call it CI. You are inside, you are using MST. But for me, I'm dealing with you like one switch. You got it? And if this is instant 1, and this is the spanning tree instant or process 2, process 1 is working for 1, 2, 3, 4, serving for VLAN 1, 2, 3, 4. 2 is serving 100, 200, 300, right? And I have, by default, instant 0. This is for these things. So instant 0 is made to talk with others. So when you are configuring MST, for example here, I'm telling him, name CBTME. What is the name? It is name of this cloud. So this cloud is called CBTME or FNG or whatever. Okay? Revision, it is a number you can leave the switch to do it by itself, or it's like VTB revision number. It is for their own updates between each other. Here I'm telling him, hey, you know something? Instant one, we have VLAN 1, 2, 3, 4, 5. And instant 2, we have VLAN 60, 70, 80. Thank you very much. I will go to do it in both switches, everything is fine. And if they are connected to a switches that not running MSTV, no issues. I have instant 0 in the background serving. It is a normal spanning tree, not a MST.
But it will take all the VLANs?
No. Here, for VLANs, they will talk about VLANs, but remember, one of these two links should be blocked. So he will talk to these two switches and try to block one of them, because he's acting with the cloud like one switch.
And that Cisco switches will talk to HP switch on not MST, on normal STB.
Normal STB, which in MST we call it instant 0. It is number 0.
So which port he will block?
Well, normal spanning tree, he will check. Let's say one of them is Ethernet and the other fast Ethernet, so the Ethernet will be blocked. And they will send the bridge ID and he will talk with them.
But HP cannot be a designated router.
Cannot be, his interface cannot be, depending on who is the root bridge.
Like, he cannot be a root bridge, he can be HP.
He can. Spanning tree is a standard protocol.
But
It's
it
not,
will-
it's not for Cisco.
STP, I think only standard protocol. This MST, it's proprietary for Cisco.
MST is Cisco.
So that's why I think HP is only working on standard protocol.
Yeah. Okay. Just 1 minute. Spanning tree configuration. We'll leave this one. They need this one. Protecting spanning tree.
It will be better if you can do like labs.
Yeah,
If you can emphasize.
Here it is.
No, like if we can do in between.
Yeah. I will let you do it. But let me explain things. We didn't finish. Yeah, we didn't finish it.
Yeah, yesterday we had only one lab at last moment.
I will let you do more labs, but we need yesterday because we spent time trying to make a basics for a few things that
Yes.
refreshing your mind about
Production.
access list and these stuff. We bring normal 2960 switches. We didn't finish. There are some tricks I need to show to you. Okay, I have two switches here. And at the same time, 10 days, for sure it will be in the time of labs. If you want to take a course. That's why I agree with you. If you want to make it 11 days, we need to talk. It is not in my if it is in my hand, I will spend all the days with you.
We have one more suggestion. On Saturday we want to come early, morning time. If it's okay with you.
No issues. In which time you want to come? It's on Saturday.
10 o'clock or 9 o'clock.
Okay, let's try to.
We will be a little more.
Let's in Thursday before we leave, let's sit together and check what we will do on Friday and Saturday. What is the timing there? Okay, here I have two switches. Because till now we didn't take any copies, only the MST. Now you have these two switches. They are connected to each other using Giga 01, Giga 02. I'm sure from here, back tracer, you can know now who is the root bridge. Who's the root bridge?
This one.
Switch 2. And switch 1 is the non-root bridge because he has one interface blocked. And as you can see here, it is blocked because it is Giga 02. The highest interface ID is the one that's going to be blocked because both are FAB or Giga Ethernet, so the cost is the same. Let's go to this switch. and type show spanning tree. Okay. What you are going to see, it's saying we have only VLAN 1 and spanning tree is working normally. And this spanning tree is the standard spanning tree, since you are seeing here IEEE. And I am giving you two parts of information. The first part is root ID and the second part is bridge ID. The root ID is the root bridge information. So if you have when you have a root bridge in your topology, his MAC address, his priority, all information about him, I will find it here in the root ID. Root ID means root bridge ID. My ID locally is bridge ID. So I am switch 1. If I want to know if you want to know what is my MAC address, what is my priority, just check under bridge ID. If you want to know some information about the root bridge that exists in this network, go to root ID. Clear? You know now the difference between root ID and bridge ID, right? Now, check this. Cost 4. Yeah, cost 4. Just gain it. If it was faster than it, the cost was going to be 19. He's saying priority is 32,769. And it looks like my priority is the same. 32769. MAC address, here is the MAC address for the root, here is the MAC address for me, and it looks like he is more better than me. In hexadecimal, I am higher number than him. So that's why you choose him for. What is the hello time we are using? 2 seconds. Forward delay, as we say, 15 seconds. And maximum age is 20 seconds. There is a trick here that I need you to understand. Do you see the priority number? Deal with it like this. The priority number by default is this number plus your VLAN ID or your VLAN number. That's why the priority here is 32,769, not 768. Why? For VLAN 1, right? Okay. Let me do something in the both switches. Yeah, let's create VLAN 12. And in the other switch, let me make it VLAN 12. And also I like to make these, make the Giga Ethernet and Giga 02 as a MAC as a trunk. Okay. Just let's wait a little bit. Till they go out. Now let me tell him show spanning tree again. And check this. He's telling me for VLAN 1, I'm giving you this information, and now I'm giving you the same information for VLAN 12. Check the priority. It is added. The priority is this. It's by default. And plus 12 for VLAN 12. It is 3278. You got it? You got why we have this VLAN number? Now, let me return back to the root bridge and say show spanning tree to the board. I have both for VLAN 1, VLAN 12, but notice this information. There's an extra line here saying this bridge is the root. So don't waste your time by reading both, because both have the same information. The priority number, the MAC address here is the same here. So the information about the root bridge, it's same for this bridge ID, because he is the root bridge. So when you see this bridge is the root or this bridge is the root, it means this is the root bridge for these VLANs. For priority, I want you to remember something. The priority is the increment of 4096. In another meaning, you cannot go and say, let's change the priority and make it 20. There is no such a thing. The priority can be 0 or 4096 or 8,000 something, 12,000 something, and so on. And this one is the default, right? And you understand something else, that the VLAN ID will be added to these numbers. So when you are going to change the priority, you need to remember that we are using these. Here in our example,
So in this example, can you show the slide? In this example, VLAN is 5 and priority is 12288. So the priority will be
I was going to tell you now about it. Give me a second. For sure, I have a plan, don't worry.
It will be 293.
Yeah. Now, what if I want to create bare VLAN spanning tree? And I want to change the mechanism here. I want to switch to be root bridge for few VLANs, and switch one will be root bridge for another. We have two options to do that. One of them will answer the question. First of all, just let me try to bring this one here. First of all, I would say spanning tree mode, and let's use bare VLAN spanning tree. I need to do the same in the other switch. Spanning tree, move, bare VLAN spanning tree, or rabbit, up to you. We create VLAN 1 and the 12. Let's create VLAN 2, VLAN 3, VLAN 4, and VLAN 5. I will go to the other switch and I will do the same. So now I have a few VLANs here and there. For now, all these VLANs is working for this switch 2 as a root bridge. So if you go to this issue of monitoring, if you go here, you will find for VLAN 3, this root is bridge. For VLAN 4, this bridge is the root, and so on, for all of them. Now I want this switch 2 is going to be the root bridge, but not for all these VLAN. For example, for the odd VLAN. And the even VLAN I will give it for switch 1. What I will do, I will go here and I will tell him spanning tree VLAN 1, 3, 5. Root primary. You are the root bridge for these VLANs. Now, in the other side, I can tell him spanning tree VLAN 2, 4, 12 root primary. So now switch 2 is working as a root bridge for specific VLANs, and switch 1 will be working for specific VLANs, which is 2, 4, 12. Okay? And in this case, this block link, board will be blocked for only VLAN 1, 3, 5. But he's running for, because he's the root bridge for 2 and 4 and the 12. That's why it's now changing to green. Why it is changing to green? Actually, it is a block for VLAN 1, 3, 5, because the other guy is the root bridge for them. But I am forward for VLAN 2, 4, 12. And for sure, switch 2 now, for these specific VLAN has one of the interfaces is blocked. Let's go to switch 1 and tell him show spanning tree. And check this. For VLAN 1, he's giving me some information. He's telling me the root bridge is that guy, bridge IDs, it's me. But when it comes to VLAN 2, he's saying, I am the root bridge now. When it comes to VLAN 3, I'm not the VLAN bridge. When it comes to VLAN 4, no, I am the root bridge. When it comes to VLAN 5, I'm not the root bridge. When it comes to VLAN 12, I am the root bridge. Because I told him you are for 2, 4, 12.
For this even VLANs, you can see that the roles for both of the interfaces is designated.
Yeah. Why? Why?
Can you, because it's a root bridge. Can you go to the switch 2 and check which is blocked for this?
Let's see. Do show span. For VLAN 1,
It's the root.
for sure I will be. For VLAN 2, I'm not. For VLAN 3, I am the root bridge. For VLAN 4, I'm not. But for VLAN 5, I am the root bridge. So,
Okay, it has blocked the
Let's get in.
interfaces.
we can do something extra. And by the way, till now, I'm giving you the first method of the two methods. Remember when I said the second method will answer your question? We didn't take it yet. Now, I can do something else. You know, I can create some redundancy things, or let's say backup stuff. I can tell switch to, you know something? You are the root bridge for VLAN 135, and you are a backup for 2412 if this switch 1 goes down. If the primary root bridge for VLAN 2, 4, 12 goes down, please consider yourself the root bridge for these VLAN. How I will do it? I will go to 4, 12, root secondary. You are not a primary for these VLAN. You are the backup secondary. And I can do the same there. For 1,